This is Deepika Rani, Assistant Professor from the Department of Computer Applications, SFR College for Women, Sivagasi. Today I am going to talk about two important CPU scheduling algorithms, highest response ratio next and multi-level feedback queue scheduling. Let's move into the topic. So, introduction to CPU scheduling. CPU scheduling selects one process from the ready queue. Goal: improve CPU utilization and system performance. The scheduling criteria are waiting time, turnaround time, throughput and response time. What is HRN scheduling? HRN stands for highest response next ratio. It is a non-preemptive scheduling algorithm, also called highest penalty ratio next. It is an improved version of shortest job first. Need for HRN. Problem in shortest job first. Long process may suffer from starvation. Short jobs always get priority. Solution: HRN avoids starvation by considering waiting time and burst time. The formula for HRN, response ratio is equal to waiting time plus burst time divided by burst time, or response ratio is equal to 1 plus waiting time by burst time. Process with highest response ratio gets CPU. HRN working procedure. Calculate response ratio for all ready processes. Select process with highest response ratio. Execute it completely, that is non-preemptive. Update waiting times. Repeat until all processes are completed. Next, what is multi-level feedback queue scheduling? Multi-level feedback queue is a sophisticated preemptive scheduling algorithm that uses multiple queues with different priority levels. Unlike traditional multi-level queue, MLF queue allows processes to dynamically move between queues based on their behavior. This flexibility allows the scheduler to overcome the key limitations of simpler algorithms like first come first serve, shortest job first and basic round robin scheduling. Why MLF queue matters? The problem: in simple multi-level queue scheduling, processes are permanently assigned to one specific queue. This fixed assignment creates rigidity and prevents the system from adapting to changing process behavior or system conditions. Solution: the MLF queue introduces dynamic priority adjustment by allowing processes to move freely between queues. This means the scheduler can promote or demote processes based on how they use CPU time, creating much more adaptive and responsive scheduling. MLF queue structure. An MLF queue implementation consists of multiple priority queues, each potentially using a different scheduling strategy. The CPU always selects the next process from the highest priority queue that contains ready processes. So here Q1, Q2 and Q3. Here Q1 is of highest priority, Q2 is of medium priority, Q3 is of lowest priority. So in Q1 the time quantum is 4 millisecond and time quantum for second queue is 8 millisecond. So the third queue uses the first come first serve. The MLF queue workflow. So first step is the entry. New process enters the highest priority queue initially. Second is the evaluation. Process runs for its time quantum and behavior is monitored. Next is demotion or exit. Full quantum, that is the process move down, or completion goes to exit system. Then continuation. Process cycles through queue until completion. This cycle continues until the process completes execution, with the scheduler continuously adjusting priorities based on observed behavior. So advantages of MLF queue. First one is the dynamic flexibility. The second is the interactive support. Third one is the adaptive behavior. Fourth one is reduced starvation. Fifth is the prioritization. And sixth is good throughput. So finally we come into the key differences between the two schedulings. That is, first one is the HRN and MLFQ. So type HRN is non-preemptive, MLFQ is preemptive. Starvation, HRN avoids through aging and MLFQ possible without proper aging. HRN complexity is moderate, in MLFQ complexity is high. HRN is best for batch system, MLFQ is best for time sharing systems. In HRN, priority can be calculated at scheduling point. In MLFQ, dynamic movement between queues. Thank you.